Would you put anything to be able to take a nap right now? And they fight that. Like, why? Why don't you come take notes, kiddo? You wanna trade?
Hey everyone, this is Rad Sanded Afkash Chef. Today we're presenting smart manufacturing in the shoe industry for STEM education. Let's start by looking at our objective. So the objective of our team is basically to design an educational tool for students in which they would be able to have an understanding of what is smart manufacturing within the shoe industry. So who exactly are we trying to target? Our target audience are mainly first-year engineering students. As for our ideal outcome, it would be mainly to design a simulation learning tool in which we could implement different scenarios of smart manufacturing technique. So why shoes? As we can see today, we're all wearing shoes. So we find it to be the most relatable product for our team. So that's why we chose it. And our ideal outcome will be later on discussed throughout the presentation. As for our motivation, it's because we were all first-year engineer students, and we could relate a lot to this old thinking of manufacturing, like we could see in this picture, Charlie Chaplin in the line assembling. So we want our user to be aware that there is today a huge transition between the old manufacturing and the smart manufacturing, in which Sandesh would be explaining in the next step.
So smart manufacturing is currently transforming more traditional manufacturing processes and makes up a big component of look at the project. And these are some key smart manufacturing terms. So with our project, we chose to focus on the shoe industry, where the central theme is customization, but on a global scale. And with this theme, these are the key smart manufacturing technologies. So currently 3D printing is used by companies to produce molds, which is later used in the casting process. This basically produces higher quality molds that last for longer, which brings down waste and drives down costs. And some companies also combine 3D printing with laser sintering, which basically helps companies create functional prototypes and at a much faster rate. So this helps companies test concepts and meet changing consumer tastes. And the last key technology used is 3D scanning, which basically uses camera technologies to create 3D models of a customer's foot, which is used later on in the manufacturing process. So 3D scanning is really the first step of the process and typically happens in stores and really drives this concept of customization on a global scale.
So like Sandesh mentioned, there are three technologies that we did our research on: 3D printing, 3D scanning, and laser sintering. But our project isn't going to be a research-based project. We're going to be creating a simulation. So this is somewhat of a process overview of the things we'll be doing in Capsule 2. We'll be collecting data, gathering data from various contacts, analyzing the data, utilizing data mining and data visualization tools that we built in IB, approaching to a final solution, working towards this dashboard solution that we have thought of in Capsule 1, model development, so prototyping, testing, getting interactive with the audience, our target audience, and the last and final outcome of this Capsule 2 project is the simulation model, which will display the metrics of a live running production cycle of the shoe manufacturing in a shoe manufacturing industry.
Alright, so in terms of our data collection approach, we're currently in contact with three major companies: New Balance, Reebok, and Clarks, as well as one faculty member, Professor Love, has been very well connected and has worked in this footwear industry, who will try to help us reach out to consultants and various other companies. In terms of the data, there's kind of three levels of data that we want to obtain, and these come from the factory level data, operational level data, and process level data. However, we're aware that we may not be able to get each one of these types of data sets. So we'll be able to work around just getting one or two of these three levels. However, we're also aware that we may not obtain any types of data from these companies, and in that case, we'll be reverting to an academic data set that we find online. Moving forward, we hope to be obtaining data and meeting up with companies and site visits and whatnot towards January.
As I mentioned previously, our target audience is a young audience. So we are aware that some students might not have been exposed to smart manufacturing concept or complex vocabulary. So our desired outcome of our tool would be three desired outcome, which is to be interactive, visual, and smart manufacturing and metrics. With what I mean by that is that we want at the end of the day our user to have an experience with our tool based on interactive and visualization, and at the same time learn about what's happening in the smart manufacturing world. Afkash will go deeper into our dashboard.
So like Karen had mentioned, there were three desired outcomes: visualization, interactivity, and some sort of metrics that the user will understand what's going on in a facility plan layout with the manufacturing plan layout. So on the left, as you can see, there are a couple of parameters that we'll be initializing in Capstone 2, and as we collect our data, we'll come to know what those parameters will be. Those parameters will essentially be shown at the bottom of the simulation, and this will enable users to click to deselect and select some parameters which will affect the output of the simulation constantly. Another key thing to notice on the simulation is that on the bottom left, there will be some additional information about the simulation, so that our target audience, since they're freshman students who lack technical knowledge about simulations, will have some sort of guidance as to what should be going on in the simulation and understand what the parameters are and how they apply to the simulation. And another key section of the simulation is the outputs, which are mentioned over here in this box, the statistical measures. For example, we've come up with 4 potential outputs that we think the simulation will produce, which are system downtime, throughput, cycle time, and lead time. We've also created this neat tool where if after the parameters entered and the simulation is running and it's producing outputs, we can identify and show the user either if the downtime has been reduced, that will be creating a positive impact on the simulation, and therefore the figure will turn green, as opposed to red if there was a negative impact on the simulation. This is one of the interactive tools that we will create. As I mentioned previously, those parameters will be shown at the bottom. But another cool feature of AnyLogic is that you can see the simulation from multiple views. So there's a 3D view, the layout view, a specific data view, and going into specific operations and machine processes, you can look at the simulation through that view as well.
So that's all great, but that's quite complex. How do we build this thing? Well, we have divided it in 4 stages. Hopefully we divided it in 4 stages. So the main stage is really about defining what we're going to build in a much more detailed manner. Right now we have kind of a big picture understanding of, okay, these parts are going to work, with these parts, but we don't really have an understanding of the exact logic of the decision node, for example. So that's what's going to happen in the first phase of the model building, which is model definition, input analysis, and trying to understand all of that through a flowchart. From there, we go into an initial model buildup, which is about implementing the mandatory requirements with base visualization. Visualizations not being the focus, but really how a shoe would flow or how a shoe is made through our simulation. And the third stage, the initial model buildup, would be integrating those desired requirements that we want on top of the mandatory requirements. So as you can see, we have really one stage of requirement which is mandatory, the second is desired, and then that takes us to the 4th stage, which is additional requirements. And that's really everything that enhances the simulation, that really makes it, funky, really cool with the colors, and really puts everything together. in stage 3 and 4, what's different, you might say, oh, it's not that different, is that in stage 3 we have an initial testing phase. Now what that is that the simulation is at a stage where we can actually test it on people and use our KPIs to kind of understand, okay, is it effective or not, and then integrate from that feedback in stage 4. Like I said, we have feedback from our users, and how do we define that? Well, we define our success with our user KPIs. We say that, okay, from our objective, we see that it's an educational tool. So how do we evaluate what is an educational tool? And then it's to understand the connection between something, between one thing and another thing. And also to identify what are these key parameters that we're changing in the process, moving the slide bar left and right, and seeing how that actually affects the simulation. So this is how we plan on evaluating if we've achieved our objective. Now, what's key to understand is that this is our focus for our KPIs. We're still to define exactly how we're going to measure that, and our idea now is perhaps to have a scale of 1 to 10 to try and understand, okay, the average user on the scale of 10 thinks that it's 5 effective. So that's kind of our thinking right now.
Alright, so moving on, so the industrial engineering concepts that we were able to relate to our project were the 4 following. Simulation modeling, as we'll be creating a discrete event simulation tool. Stochastic modeling, as there obviously be queuing theories that go in the manufacturing process. And then lastly, quality assurance along with probability and statistics, as these tools will help us analyze the data that we obtain and then help create an effective and accurate simulation for that. So this is just a timeline that we created. Capstone 1 shown in light orange, and we're currently at the initial approach to tool and feasibility stage, and moving on, there are 3 major stages that we anticipate on approaching in Capstone 2. Thank you.
So it's a good idea, and it's going to be really helpful for our freshman students. And I have a question about the scope of your project. So you are considering a shoe manufacturing system. So my question is, which part of that system you're going to focus on and create simulation models for? Because you have 3D printing for measuring data, and also the assembly line, all of those things. So I'm wondering what's going to be your scope that you're going to use simulation to model this. Plus, I want to know if you're using simulation. I've seen the demo of AnyLogic. So if you're planning to use AnyLogic, are you prepared for that, or have you have any idea or knowledge about it or not?
Right, so I think your question has 2 components. So the first one is that we are looking into focusing on a specific smart manufacturing technology because, as you mentioned, it's quite complex and there are many parts to it. So some of the parts of the process will be perhaps on a more bird's eye view, just saying, you know, inputs, it goes through the process and this is kind of what happens through the output. And then the focus would be, in our case right now, would be something around 3D printing. So we're going to have all the components for that process in detail in there. And then the others will be there, but in a much more elementary way, just to not get into too much of the details of that. And the second part is, as you know, AnyLogic is quite complex. So we're looking to do all the tutorials that we need in order to at least do the initial model build-up. And then from there, we hope if we can get the software to have some kind of, we have more extensive support from the resources that they share. But if not, we can even through the student edition, we can kind of, with online tutorials, we can kind of figure out that way. But we do have that, we have identified that that's quite complex to learn. It's not intuitive at all. We do have to have that training.
And so, like, in terms of like, we've kind of set up an internal deadline. So by the time we come to Capstone 2, September, January 7th, January 5th, back to the school, we all as a team individually would have done probably all the tutorials that are available and understood how AnyLogic works and tried the free edition in order to play around with the tool. Some mock data that we can just enter by ourselves.
So, say you make this entire thing and you test it and it works out really well, people really like it. Where does it go from there?
Right. So that's a really good question, actually. So the idea is that if it works really well, whether it's faculty or anyone who really teaches first year students or anybody who interacts with first year students will have that available. Or I don't know if you're familiar, in the basement of Snell, there's that earthquake simulator. So, or have it in an exhibition, something like that, so people can really interact with it and it's like open to everybody. The other idea was perhaps to have some kind of talk with a museum, or somehow, not even maybe a museum, but just see if we can develop it as a software package moving forward. But that's way beyond our scope of our project. It's more so once we reach that that outcome, we will evaluate how we stand and how we feel about it moving forward. But that's kind of just our rough thinking right now.
Two questions, right? Right now, it seems like the presentation is very focused on the simulation aspect of your product, and not so much on the educational part of it. So I'm wondering if you guys have started doing some research, right, on the educational aspects of all of this and how to evaluate a tool like this, etc. And then, so that's one part. And then I lost my, so I'll let you answer that if I remember the other part.
So we have started doing some basic research in terms of that component, but right now our primary focus is on trying to build the tool and see what steps we need to take to build the tool. But that is a component that we are taking seriously and we'll take a deeper dive into.
And then my other part was, why did you guys chose simulation as your tool for educating students about smart manufacturing as opposed to any other IE tools?
I think with a simulation-based tool, it's the most interactive. So you'll be able to see, just like Avkash mentioned, there'll be a lot of views. So you can dive into a specific process-related view, like one operation, or you can see how whatever the user inputs, how that affects the whole manufacturing line. And so I think that's what makes it very interactive and educational for the user. We're trying to make that as simple as possible, as well as informational as possible. So I think that a simulation tool helps do that.
Are you planning to also create sort of like a exercise or something like that to go with the simulation that guides them through the learning process, or is it more like exploratory for them to just try things?
So there's, just to add on to what Ralph said, so our motivation also, we briefly mentioned it, was that we came in as first year students, and of course there is a lot of visuals and we have a lot of information, but we can't see actually how it works. You see, even if someone doesn't have a technical background, just seeing that video, they kind of understand, okay, there's some kind of a conveyor belt, parts are moving around. So we think that that aspect is unique to simulation, and it integrates a lot of the metrics in an accurate way. The second part of your question, well, we think that, what was it? Sorry.
Like if you're planning to also create like sort of like an activity or something that goes with the simulation to guide students, on how to use it and explore it and get the best, learning from it.
I'll need to stop you.
Sorry.
For a sentence or two next
Yeah,
week, and
just-
then you can work on it from there.
Yeah, so just a sentence. So we planned initially to have, to evaluate our user KPIs, to have scenarios, scenario 1, scenario 2, scenario 3. And then from there, you could just play around what you want, but have some kind of guide. Yeah. Sorry, I forgot the first part.
Yeah, no, that's fine.
All right, thank you very much.